Okay, so in this drawing detail we've got a combination of what you would be used to as just of two details. What we have is the top and bottom of a window, and add to that then we've got the eaves detail of a roof, of a lean-to roof built off the side of a house here. Okay, so quite a bit of work. Again, it looks like quite a bit of work, but if you're to break it down to one step at a time and do the bottom of your window, do the top of the window, and work your way across through the rest of it, it becomes quite straightforward if you can break it down into those parts. So we're going to get straight into this. The important points to note are, as always, we have a board and title box laid out nice, neat and tidy. In this particular drawing we have the page laid out in portrait orientation, so make sure that you have the page laid out like so. And our equipment required are T-square, we've got our 2H pencil and our H pencil, rubber, our pens, 60-30 set square and a 45-degree set square. Okay, so that's everything we need. We're going to get straight into it, and we are going to start this drawing with the bottom of the window, and we're going to focus just on the bottom of the window. We're dealing with a solid concrete cavity, a standard concrete cavity wall here, usual size of 350 millimeters. So we're going to down very low on the bottom of the page. We're going to start drawing some of the. We're going to draw maybe 3 blocks of a cavity wall. Okay, so nice and low. I'm going to bring the camera down here a little bit. I'm going to zoom in a little bit closer. As always, we're going to do our work nice and light and nice and low on the page. I'm going to start off by drawing I'm going to pick a random point here on the bottom left of my page, and I'm going to draw a light line up. Okay, that's going to be the outside part of my wall. I'm going to just draw a light line across as well, and I'm going to measure the parts of the wall then. So we've got a scale of 1 to 10, so 100 millimeter outer block, that's 10 millimeters, 150 millimeter cavity, and a 100 millimeter inner block. Again, everything light so far. I'm going to extend that line up a random distance, nothing set just yet, and up there also. Okay, so again you can see that those have been drawn up lightly. I'm going to go up to a point somewhere around there, and I'm going to just draw a line across, and I'm going to say, that's going to be where my wall is going to stop. Okay, from there I'm going to just mark down 2 or 3 blocks. The height of a block, as we all know, is 225. When we scale that down, that's 22.5 millimeters. So 1, 2, and we might get a 3rd block in there as well, yeah, just slightly further. Let's extend that down. Alright, so what we've got there then is 3 blocks. Again, I'm remaining light with all the work. But basically what we have there is some block up there, and I'm just going to rub out that initial line now, and that's going to give me those there. Okay, so that is the starting wall, and we're going to work from there. So basically what I've got is this bottom part. Without the windowsill, we're going to build that windowsill in there in a moment. Okay, the next thing I'm going to draw, you'll notice that this top block is going to be cut out a little bit. That's why we did things lightly. So we'll do that shortly. But I'm going to just draw in the insulation here, first of all. But just above that insulation, something that's missing off this drawing is actually cavity closer. So I'm going to draw in a cavity closer first of all. So the insulation is 100 millimeters. So that's 10 mil there. The insulation is going to go across like so. Alright, so that's going to be the position of my insulation. Before I draw the cavity closer or the rest of the insulation, I'm going to actually draw the position of the windowsill. These windowsills, now the thing with windowsills, I've got a size there of 210 millimeters by 100 millimeters. They can vary in size and they can vary in shape. Okay, so I usually go by a standard size of 100 millimeters that way, 210 millimeters that way, and after that you can just draw in a shape similar to that. There is room for variation on that. Again, the position of this windowsill, it's handy. It can vary also. Some windowsills go all the way across there, they're resting right back. Some rest just on this block wall. It's just handy to have our windowsill resting right up against the insulation. So I'm going to draw that windowsill. I'm going to measure 100 millimeters down, which is 10. And as I said, 210 millimeters across. So lightly I'm going to draw there. I'm going to rub out some of this border. 210, that will be 21 millimeters across like so. I'm now going to rub out that block there. So that block would have been cut out by the block layer, or possibly a smaller block used. So there's my 100. There's my 210. After that, I'm going to just draw in a similar shape to what the windowsill should look like, because that can vary from manufacturer to manufacturer. So that's going to be the windowsill I have there, resting on top of that block. Okay, now cavity closer, we're going to make it 40 millimeters. That can vary in size for sure. So 4 millimeters. Cavity closer, we've discussed what they are. That's going to rest across there. And then our cavity insulation is going to just go the rest of the way down. Okay, at this point, we pretty much have that all done. So we can now go heavily over these details. Like so. Let's get those blocks correct. I'm going to just do the symbol work for that insulation there also. So this is my cavity insulation. Over this side then, on a 45-degree set square. And that's that insulation there. And then there's some rigid insulation inside that cavity closer also, so that's a separate little entity there. Like so. Okay, so at that point there we pretty much have the bottom part. We are now ready to draw in the window frames. We've got a fixed triple glazed window frame here. The size and the shape of this window frame can vary. Alright, so I have 150 by 100. It's quite a big window frame. You can do a smaller one if you like. You can do a slightly bigger one. The shape, if you want to do nice and simple, can be a straight rectangle. I just like to put a small bit of a design on the corners of those to make it look a bit more attractive. Window frames often vary in shape and size, so there's not too much, I wouldn't worry too much about that. The position of the window frame also, generally just somewhere central across there. I can start there, we can start here, whatever you prefer. Okay, I'm going to start my window frame here, similar to what I had in the other one. And I'm going to stick to the size that I have, so 150 millimeters, it's 15. There to there. As I said, this window frame could be sitting slightly more over that way or that way, whichever you prefer. And lightly, I'll just zoom in a little bit more here. Lightly, I'm going to just draw a rectangle first of all. So 150 by 100, that's 15 millimeters by 10 millimeters. Okay, that's what we have. Again, we've got triple glazing. Okay, I'll draw a little angle. Again, I'm not even going to think about the size of that angle. I'm just going to do something similar there to give it a bit of an aesthetic look. I'll rub out those corners now. And then that's the shape of my window frame. And from there, again, I'm not going to overthink it. I'm going to come in about 2 millimeters there and about 2 millimeters there, and that is going to where I'm going to have my window panes slotting into place. Again, how far down here are we going to go? Use your own judgment. I'm just going to go down 5 millimeters there, and my window panes are going to slot into that position there of the window frame. We've got some insulation. Modern window frames nowadays have insulation in there, or as they're known, they're thermally broken. That allows or stops heat from escaping through through the building. So modern window frames now have actually insulation built into them. So there's more insulation there to stop thermal bridging from occurring in the building. That's the window frame there. Okay, we'll draw the glass in shortly afterwards. What I would do next, before I even start drawing the glass in, I'm going to start drawing the position of the top of this. Alright, so what I'm going to do is I'm going to extend all these lines up, because it's very, very important that the top of your window frame matches exactly with the bottom of the window frame. So I'm just going to zoom out a little bit more. With my 2H pencil, I am lightly going to extend the position of the blocks. I'll do that first of all. So these are just the positions of the external block work and the internal block work. I'll then extend up the position of the window frame, which actually matches up quite well with the block work as well. I'm going to bring up these lines here too. The height of the window, you can make your own judgment. As we all know, windows vary in shape and size, so we're not going to overthink that. Don't make it too big. We want to make sure this drawing fits on the page. So I am going to draw a line, make it a quite small window, let's say. I'm going to draw a line just across there. And that line that I just drawn, I'm going to make that this line here, just the start of the blockwork where those concrete lintels are in place. From there, I'm going to draw the exact same window frame, except facing down the other way. Or maybe I'll extend up that blockwork a little bit more first of all, so it's more clear to see. Like so. I will draw the window frame now. We said it's 100 millimeters in height, that window frame. So lightly, I'm going to just do the outline of the window frame first of all. I'm going to put those little 45-degree angles in the corners of the window frame to give it an attractive look. Like so. I extend that line across to there, and we went down 5 millimeters in that position, and there's my window frame in place. I now need to add the insulation inside that window frame, like so, to make sure that there's no thermal bridge in that window frame itself also. Like so. At this point, I will just rub out these lines here now, just to avoid any confusion. By extending those lines up again, we could see that it is perfectly matched up, which is important. The wall has to match up exactly at the top of the window and the bottom of the window. And I'm now going to just draw in the place. Alright, again, I'm going to make the thickness of each of those panes of glass roughly 1 millimeter. I'm not going to overthink them. I am going to just use my own judgment once again, and I am going to go, let's say, up to this position here, and I'm going to say, without even measuring, I'm going to mark those little dots to outline the positions of them. So you can see there, you want a nice sharp nib on your pencil here. There's the first pane of glass. Again, I used my own judgment. I didn't even measure, roughly 1 millimeter. Here's the inner pane of glass. And then the middle pane of glass. Use your eye, use your judgment, make those evenly spaced apart, like so. We've got 3 panes of glass in position there. Right, so we're going to continue on to the upper part of the wall, and just for the sake of making sure it fits on the page, we're going to just draw the concrete lintels and maybe 2 more blocks. And then we'll start drawing the roof. If we were to do 3 or 4 more blocks, it mightn't fit on the page. So there's going to be 2 more blocks on top here. The concrete lintels are 70 millimeters in height. So I will just, on each of the walls, I'm going to measure up 70 millimeters and draw their position. I'm going to just mark some reinforcement steel inside of those, and I'm going to mark 2 more concrete blocks. So 22.5 and 22.5. So I need to extend those lines up a little further, which is fine. 22.5 there. And I'm going to draw in the second block. Mark those there. And that's the external, the cavity wall up on top also. We're going to add our cavity insulation there, or sorry, we're going to add our cavity closer. So we've got a 40mm cavity closer going across there, as always, which we learned about there. And we're going to put our cavity insulation then, 100mm cavity insulation, like so. And there's going to be cavity closer on the top of this also. So we're going to draw our cavity closer on the top of this, like so. What about that line there? So we'll just put in the symbol work for all of those, just as we go along. Like so. We have that there in addition. We've also got some insulation to draw inside the cavity closers as well. Like so. Okay, now when it comes to the top of a window, there's often an extra bit of insulation, kind of cut a bit at a bit of an angle, so roughly the height of a block. Just added insulation there just to try and prevent any thermal bridging getting in through, any cold air escaping through that part. Just any openings, you've got to double up on your insulation to make sure we've no heat getting through. So get that insulation up there also. Like so. Okay, so that's pretty much the top of the window done, and we're ready to start working on the top of the wall. We might as well put in our DPC in a few positions there as well. So we have got above a window, you've got an extra bit of DPC coming across there, black paint, down here, over the front of that, and it can go down just underneath there as well. Again, that stops any rainwater getting into the building. And there's also DPC wrapped around the back and the bottom of the window sill itself. Okay, and that's those positions done there. Just going back to the bottom of the window, so we can add a window board. So inside your homes, you can see there's a piece of wood on all your window sills, let's say 20mm thick, and you can just freehand a little curve there on that also. That can extend out further if you like. The window boards can vary in size. Okay, let's go to the eaves detail now. Eaves detail is work that we would have looked at before. We've got a traditional cut roof here, we've got slates on the roof, so we now need to draw in the wall plate on the top of the wall, and then we're going to draw the rafter into place, we're going to draw the joist into place, we're going to draw the battens into position, and then the slates. It looks quite daunting, it looks like a lot, but as we always say, one step at a time. We can build this up and work from there. We all know the slates can be a tricky job, but we've looked at that with worksheets, etc. as well. So our wall plate once again is going to sit on the block on the inner side of it. I'm actually going to just rub out some of this because we may need some space over here to draw that in. So I'm going to put into place a 70mm wall plate, so 7mm up. Again, the wall plate is simply a length of wood that is nailed to the top of it, and when we're looking at the end of a piece of wood, we join the diagonals to represent that. Okay, angles of roofs can vary depending on the design and the architect. We are going to, just for the sake of handiness, we're going to use a 30° set square to put a 30° angle on the roof. And don't forget your bird's mouth. Okay, our rafter needs to pass through a portion, about a third of the wall plate itself, to justify the bird's mouth, that little joint there. Okay, so I'm going to pick a position roughly there, and I'm going to draw the bottom of my rafter up there, pass it through there, and extend it on out here as well. I'm not going to go too far out here because we're running out of space on the page, but that block there, different circumstances, they can be notches cut out of the blocks. The blocks, they could use smaller blocks sometimes, so you can just draw it straight through there. If you want to rub out a portion of that block and have the block go a bit shorter, that's fine also. Okay, I'm going to just stop this. Again, that can extend out further, you can use your own judgment. I'm going to stop it just roughly there, and I'm going to just draw a line up like that. Now, our rafter is 150 millimeters thick. That's the standard size of a rafter. 15 millimeters. I'm going to mark a dot there. I'm going to get my 60-30 set square, and I'm going to extend another line to represent the top of the rafter. Relatively light work at the moment, just marking all those positions. I'm going to rub out more of the border just so there's more space to see what we're doing. And that's my rafter in place. Okay, now maybe just for the sake of positioning everything, I might just pick a place for where the rafter is going to go to. How far across does this go? Like this lean-to roof? Again, depends on the architect, depends on the design. We want to make sure it fits on the page, so I'm going to go, you know, roughly to maybe this position here, and I am going to stop my lean-to roof there. I'm going to draw a line straight down, and that's going to represent the cavity wall over here, which I'll be drawing shortly. Okay, so use your judgment on that. And I'm going to focus solely on getting the rafter and everything else done first of all. So there's the rafter in place. Important to understand the principles of that. The carpenter puts those into place, and make sure that your rafter goes through that there. Now, next thing that we're going to do is we're going to get our joist. So under nailed to all the rafters, there's a joist piece of wood that goes across there. Again, standard size is 150 millimeters. The joist must rest on the wall plate here. It's nailed to that. So first of all, on top of the wall plate, I'm going to extend a line across like so. I'm going to measure up 150 millimeters, which is 15 when we scale it down, and I'm going to draw that line across there. The joist will go all the way across to the end of the rafter, and they're cut off from there. I'm just going to rub out that line there now, so that we can see the joist is passing through there, like so. Okay, as you can see there's insulation in between the joists, but we'll look at that shortly afterwards. Now, the next thing that I want to work on, maybe just to keep the thing moving, we're going to draw in our fascia and our soffit and our gutter. Size and position of fascia and soffit can vary, generally around 20 millimeters thick, right? And the gutter can vary in size too, so we're not going to overthink it. How far out do we go for it? Again, depends on the design of the house. I'm going to just draw in a line here to represent the soffit, like so, and then my fascia board is going to go out past that also. Now 20 millimeters thick a fascia board, and we'll draw that in. Generally the fascia can go a little bit below the soffit, like so here, and we have that position drawn in then. Now the top of that we'll draw in once we get the positions of our slates and tiles and so on as well. Okay, so we're now going to move on to the slates and the battens, which is quite tricky work. There is a video and a worksheet on this channel as well that you can look back on also when doing this, right? But as usual, the slates overlap one another. There's usually roughly a third of a slate, then half a slate, and then a full slate, and they overlap all the way up, as you can see in the previous video that's been done on this. Page 81 of your Construction Studies revision journals gives you some good sizes to work off of on that. So generally we come out 50 millimeters from the end, and then we kind of work our way back to get the positions of the battens. 250 for the first batten, then 350, and then 250. Those measurements are 250 centres, so from centre to centre, to get that right. That is why we didn't actually finish off the top of our fascia board, because we want to just measure out that first of all. So what we're actually going to do is, from this position here, we're going to measure out 5 millimeters, and that's where each slate is going to end. So I put a little dot there, we'll measure out 5 millimeters. Now, I want to find the position of my first batten. The first batten is 250 millimeters up, or the center of the first batten. So there is 250, or 25 in the scale down. That will give me the center of my first batten. The second batten from this point is also 350. Okay, so there's the center of my second batten. From that second batten then, every other batten is just 250, 250, 250, all the way up to the top. And for this particular drawing, we're going to draw every slate batten all the way up to the other cavity wall. So 250, 250, and 250 will go from there. Okay, those dots all represent the center of each batten. Now each batten is 50 millimeters by 25, so 50 mil up this way, 25 up this way, and 50 millimeters that way. So I'm going to just measure up from here. I'm going to set 0 on the top of the rafter, and I'm going to measure 2.5 millimeters, which is 25, and I'm going to draw a light line all the way up to the top. So that's light drawing, very important. That's a light line. That will show me the position at the top of each batten. Okay, now to draw in the position of each of those battens, the best thing to do, as we said, they're 5 millimeters when scaled down. I'm going to get that dot, and I'm going to set that at 2.5 millimeters, and I'm going to go this way and this way to get my full batten drawn in. I'm using my 60-30 set square in various ways, and that basically gives me the first batten. Again, we draw a diagonal to represent the end of the piece of wood, because that's what we're looking at there. So we'll look at that again. There's center, so there's 2.5 millimeters. So we go left, we go right, and we're going to draw in the next batten, like so. I'm going to go up now and do the same with all the rest of those battens. So you can watch as we do that. Up at the very end there, we're going to just draw a batten up nice and close to the wall, as you can see there. So at the very end, there'll be a smaller gap just to get, there needs to be a batten up there. So I'm just going to draw a batten right up tight to the wall as well. So it's going to be easier to get the last slate tight up against the wall. I'm going to just go heavily now over the tops of those, like so. I'm going to rub out that line, that guideline that I drew. Just for the sake of neatness. And I'm going to draw in all those diagonals there now next. So I'll just draw this, a habit. I'll just do them all one way, and then I'll do them all the other way. Like so. Okay, all of our battens are drawn in. What that is going to help us do now is actually finish off the top of the fascia board down here. We can draw in our tilting fillet, which is a piece of wood just to help guide things up, and basically our fascia board will just line up exactly at the top of where the battens come down and where the slates come down. So if I extend that down, that will allow me to say my fascia stops here, like so, and I can draw in a tilting fillet then, just a random angle like so, piece of wood supporting the back of the fascia and guiding the felt away, which we'll look at. Now, when drawing those slates in, as we all know, a full slate is 600 millimeters. The thickness of a slate is just basically the thickness of a line. It can get messy, but it takes practice to get it right. So the first slate though, it's roughly a third of a slate. It's actually going to be 250 roughly. So 250 millimeters. I'm going to go to the center, the top of the slate, and I'm going to set 0 on that. 250 will bring me to there, and I'm going to draw a nice thick and heavy line down like so. It goes out past that. There's the first slate. Okay, the second slate is going to start here. That's going to be 350. So there's 350 there. Again, just maybe try and have the tiniest of gaps between those, even though in reality there wouldn't be. For the neatness of your drawing, it can help to look like that. Second slate 350, first slate is 250. The first full slate, 600 millimeters here, and I'm going to extend that down like so, and that's going to be a nice thick line. You can see that resting there. The rest of the slates are all full slates now, so I'm going to go to the center of this batten, 600. Again, just have it neat there, 600, so there's a nice overlap, so no rainwater can seep in. Center of the batten again, 600, like so. Center of this batten here, 600, like so. Center of this batten, 600, like so. And work our way up the same way, nice and tidy. And then that last batten, it can be a full slate as well, just for extra overlap on that. Okay, and that brings us up to the top of the lean-to roof. Now, a couple of details we need to add. The rafter itself is not just nailed to the concrete, there's a wall plate nailed to the wall, so a length of wood is nailed to the wall and the rafter is nailed to that. So the that particular wall plate is 200 millimeters by 50, so I'm actually going to measure out 50, so 5 millimeters out from that. Get my rubber, just rub out a part of this rafter, and I'm going to make that 200 millimeters starting from the top. So from here down, I want to make it 200. Like so. And then we're looking at the end of a piece of wood there, so we'll join the diagonals like so. And as well, there's also going to be a wall plate here. This joist is going to be nailed to a wall plate here. So I'm going to measure out 50 millimeter thick wall plate, and this particular wall plate will be the same size as the joist, 150. We're looking at the end of a piece of wood there, and that's what we have. Okay. A couple of small details to add before we move over to the other wall itself. We're going to add this insulation. There's 2 layers of insulation. We've also got an eaves ventilator. Right, we need a vent here for air to pass up. If we have that insulation stuffed up against there, it'll block the air from coming through. So the eaves ventilator is going to go here. Size and thickness of the eaves ventilator can vary. The important thing we do with our eaves ventilator is just make sure that it goes from here out to there, so the air can pass through. Usually 3 or 4 millimeters thick will be fine, so 30 or 40. I'm going to draw an angle here, and again I'm going to make it roughly that length. And there's my eaves ventilator in place, like so. So the ventilation can pass up through here, through the eaves ventilator and up into the roof. We can then just draw in our quilted soft insulation. Like so. And houses nowadays are very highly insulated, so usually there will be a second layer. So that goes down like so. And again, you can see there's room now for air to pass up through there. We'll just draw a second layer of that now as well. I want to just make a light guideline to help me with that, 150, to make sure it's the same height. Light guideline, and we're going to do the same thing. Like so. And just sort of stuff down like so. Okay. That will now allow us to move on over to this side of the drawing. And basically all we have to, the hard part is done now. All we need to do is we're just going to draw a part. So this is like the main building here, and this is like an extension built off the side. So this is a cavity wall of the main building. You know, we don't need to go all the way up, we don't need to go all the way down. We'll just draw a little bit above the roof and a little bit below the roof, and when we're drawing that. Okay, so we have a line drawn here already. We're going to draw the positions. Again, it's a standard cavity wall, so 100mm block, 150mm cavity, and 100mm block. Extend those lines down. Randomly, like so. Now I'm going to rub out a little bit of that title box because we may need part of it. I'm going to just leave it as it is for the moment. The blocks, we might as well just line them up. If I was to line up the block work, so there's the positions of some of the blocks joints, so we might as well just draw in the first couple and go from there, like so. And then we have to add our 22.5 the rest of the way up. So 22.5 all the way up. 22.5, 22.5, 22.5. I will just get one more block in there in case it's needed. Now we'll draw in each of those joints, like so. That wall. We've got insulation. The insulation always goes on the inner side. You have to remember this is the inside of the house, so this insulation will actually be here, like so. And you could spend a long time actually doing the symbol work for that insulation. I'll just do a small bit of it. Again, exam situation, don't spend forever on it, but just come back to it, maybe leave it and come back to it at the end. Do a small bit of it and then leave it and come back. I'll just do that much for the moment, for the sake of time. So it's rigid insulation on the inside of that cavity wall, like so. Now we've got some felt, some DPC and some lead flashing and stuff. A lot of little slight small details to add here. So if we were to look at this finished article here again, underneath the battens we've got roofing felt all the way down, so we're going to use blue pen to draw that in all the way down to there. It goes up the tilting fillet and down. We've got some lead flashing, so there's lead flashing on the corner here to block the rain from getting in, but there's also a piece of lead flashing built into that joint and it comes down, so it's doubled up to stop rain getting in there. So you've built into that joint, it comes down, and it's also put into the corners there and it's bonded together. Then we've DPC coming across like that with black pen to add to the waterproofing of the wall itself. So blue pen we use for the roofing felt itself, so it's just basically a blue line all the way across the top of that rafter. The carpenter's job is to put down that roofing felt. I'm going to use a red pen for the LED flashing. Go to one of the joints above it, that's a bit close, so I might go to the second joint above it. The LED flashing will be built into that joint there. It'll come down straight like so. There, that's the first piece of LED flashing, and then there'll be a piece of LED flashing added, and it goes around the corner like that. That adds to the waterproofing of that little joint there. It's called the abutment, and it's very, very important that that is made waterproof and no water can slip in there and start getting into the roof itself. We've got DPC then, the DPC work comes across that joint there. It'll come down and rest in also to that, above that LED flashing as well. That'll stop any rainwater getting up in through the wall as well. Okay, so you know, at the end, sometimes people like to do their DPC work as they go along. Some people like to do it towards the end, but that's pretty much the drawing complete in terms of doing it up. Quite a bit of work there. You then have to get to the stage where we do our labels. As always with the labels, nice and tidy with them. Don't make it become too messy, and label as much pieces as you can. The best way to do it, I think, is with straight lines coming out of the different parts of it. We won't label anything twice, so if we do all the wall and stuff here, we don't need to label the wall over there. So I'm going to bring out the, some lines over here. We've got loads of space over here, so I'm going to bring out some lines to label all these parts of the wall itself. So I put a little dot on the end of those lines as well to help you understand what we're labeling. So we've got a 100mm external block. Just zoom in a small bit more there. Block. Nice and neat writing. We've got a cavity. We have got our 100mm insulation. And 100mm internal block. Okay, we have got a windowsill, so 100 by 210mm concrete sill, or windowsill, whatever you want, windowsill. Labeled there. We'll do the window frame itself, so we said 150 by 100, that can vary in size, but we went for 150 by 100mm window frame. It's thermally broken if you want to add that as well. We will add DPC, actually there's just DPC wrapped around that windowsill also. DPC. Triple glazing we'll just add there. You can label the cavity closure if you like also. I'm going to label this 100mm by 70mm lintel. We have most other things labelled. We don't need to label these blocks again. You can label that DPC work. DPC. I might just come down here and label the joist. 150 by 50mm joist, and I'll just label the insulation as well. Insulation. Now we'll just use this space up here to label the other roofing members, so the rafters and so on. So we will come out here at a 60-degree angle. And I'm going to do 150mm by 50mm rafter. 150 by 50mm rafter. 50 by 25mm batten. We've got roofing felt. The blue line. We've got a 600mm slate. as well. So the eaves ventilator varies in size, so we'll just label it as the eaves. Eaves ventilator there. Gutter, I have enough space, you can draw in your own gutter there where needed. Now, just two important things, we get the LED flashing and the DPC labelled up here as well, just as they're important details for waterproofing. So LED flashing, and we've got DPC as well. I'll just label that over here. And that would be pretty much the whole thing labelled, and that drawing complete there.